All right, it says which equation represents a parabola that opens up with a minimum of 3 and has an axis of symmetry at 3. So I notice right off the bat that all these functions are written in vertex form. What does that mean? Well, when I say f of x is equal to a times the quantity x minus h squared plus k, I know that the vertex, this is why it's called the vertex form, occurs at h comma k. Well, one thing I know for sure is that in order for this to open up, a has to be positive. In other words, it has to be greater than 0. Okay, well, look, all of these technically have a 1 in front of them, and 1 is greater than 0, so we're good there. So in all those scenarios, a equals 1. But wouldn't it be great if I knew what the vertex was? Well, the vertex, if you think about this, we're told that the line of symmetry is at x equals 3. So if I go over 1, 2, 3, there is a line of symmetry at x equals negative 3. The vertex is always on the line of symmetry. So that means that it's going to be somewhere here. If I just knew the y value of it, I could graph the vertex. Well, I do. I do know the y value of it because it says it has a minimum value of 3. So that means at 1, 2, 3, why did I write down negative 3? That's 3. So that means that at 3, this is my minimum value, okay? And that's where the vertex lives. So in essence, what I'm saying is that the vertex, the x value, is going to be the same as, well, let me write it this way so it's color-coded for you. It's going to be the same as the line of symmetry. Okay, and then the y value is just going to be the min or the max, whatever they give you. Well, what's the x value of the line of symmetry? 3. What is the minimum value? 3. So now I know that a has to be 1 because those are all my options. So now I could just plug it into the formula. I could say f of x is equal to 1. I don't need to write the 1 down. X minus h. But what's h? 3, right? Because this is h comma k. Which is also, we say h comma k for the formula, but it's really the x comma y. So my h value is 3. I just plug in the 3. The formula has the minus sign. That's squared. And then I just add k. What's k? 3. So which one is that? Is that C? C is the correct answer. And then if I were to graph that on my graphing calculator, I would see that all those points are true. So let's plug that in our graphing calculator. So I'm going to turn on my graphing calculator. Remember, I want you guys to practice doing this too. We're going to hit y equals, clear that out. Clear that out. On my first one, I'm going to open parentheses. I'm going to say x minus 3, close parentheses. I'm going to hit this caret symbol. That puts me in the superscript. Then I'm going to hit 2. To get out of the superscript, I'm just going to hit the right arrow. In fact, let me make this a little bigger so you can see it. Plus 3. So make sure you have that entered in there. I can leave that up there for a second. All right. Then when you hit graph, this is what it looks like. And as you can see, this point occurs at 3, 3. So let's take a little snapshot of that. And it really does fulfill all the requirements, right? This right here is the point 3, 3. What do we know about that? It's a minimum. It's also known as the vertex. Okay. The line of symmetry occurs right here at x equals 3. Okay. And then the range on this, that's why it's called a minimum value. The range for this particular function is y has to be greater than 3. So y is greater than or equal to positive 3. In other words, you'll never have a y equals 2. You'll never have y equals 0. You'll never have y equal anything less than 3 you won't have because of the shape of the graph. Okay?